So we left off on, yeah, we left off on number 3. We were kind of in the middle of number 3. So let's just go ahead and start that one over again. A, I believe we said that A was true. Is everybody okay with that? I'm looking at number 3 on my review sheet. Are you all looking at number 3 on the review sheet? And we said A was true because when a curve is when a function is negative, it means y is negative. It means you're under the x-axis. And so A was true. B was false because when we say the rate of change is decreasing, that means the curve must be concave down. Now, that is different than rate of change negative. Rate of change negative means the curve is going down, right? This says the rate of change is decreasing. All right, what about C? True or false? We have a point of inflection at -5. True or false? True. Because what happens at a point of inflection? The concavity changes. We go from being concave down to up or vice versa. How about D? The function is positive and its rate of change is positive from 5 to 10. 5 to 10. The function is positive. Is from 5 to 10, is the function positive? Part of it is, right? From 5 to 8, we're negative though, aren't we? So that's a false statement. The horrible thing about true and false is it's right or wrong, right? There's no partial credit, so you gotta read it very, very carefully. All right, number 4. Use the values in the table to answer the following. All right, so the table is F, and we're going to find G of 1. Well, when we find G of something, don't we just plug that in? So we're going to plug 1 in. So 3F of 1 plus 2 minus 1, plugging in 1. So that's 3F of 3 minus 1. What's F of 3? I should be able to get that out of my table. Hopefully. F of 3 is 5. So did you get 14 as your answer? Beautiful. Everybody okay with that? Now, G of K, so G of something is -7. Your job is to find K. Remember, this is how the function is defined. So G of K will be 3F of K plus 2 minus 1. G of K, let's put a K in there, would you agree with that? And then maybe add 1. Divide by 3. Now, what does this say? This says F of something is -2. So let's look at our chart. F of what is -2? 8. So this has to be 8. F of 8 is -2. So K plus 2 has to be 8. Would you agree with that? And if K plus 2 has to be 8, then K has to be 6. Part B. using the same table. Part B says I have a new function, not G, but P. And P, oh, I gotta write out what P is, they don't tell me. P is going to be, you have to have a horizontal dilation to F by a factor of 3. So what does that look like? If I'm gonna have a horizontal dilation by a factor of 3. F of 1/3 x. Everybody okay with that? That's my horizontal dilation. A reflection over the x-axis. Reflections are negatives, and over the x-axis is out here. Over the y-axis would be in here. And a vertical translation by a factor of -4. You okay with that? All right, so we're gonna have P of 3. So we're gonna do just what we did, the problem I just erased. So plug in 3. So if we plug in 3, don't we get this? And F of 1 is 7. So -7 minus 4. I got -11. That was a negative out there. So -7 minus 4. Now the next one is a little wacky here. I need P of x, so that's this, to equal f of x. Now, if you think about this for a second, this is already set for you. This is your chart, right? And in your chart for f values, are there any fractional inputs? No. So that means that if these are going to be equal, that means x has to be a multiple of 3, so we don't have any fractional inputs. We can't have any fractional inputs. So x is either going to be -3, 0, 3, or 9. So far, am I making sense to you? If you let x be 7, then this would be 7/3. Is that in your chart? Remember, these have to be equal. Is that in your chart? No. So in order to make this a whole number, so it will match this, which is your table, x has to be one of these numbers. Those are all the options. Okay? So, you guys over there, I want you to see if this is true, if x is -3, right? You guys over there, you're going to put in -3, and you're going to see if that's true. You guys in the middle, you're going to put in 0. Put in 0 and see if it's true. You guys do 3, and I'll do 9. Okay, so I got no. Mine didn't work out. When I put 9 in, I was checking 9. When I put 9 in, on this side I got -9, and on this side I got -6, not equal, so that didn't mean answer. Did any row get it to work? You guys did, and what were you?
-3.
-3 worked. So let's just double check them. That would be negative f of, if they put in -3, it would be -1 minus 4 equals f of -3. So f of -3 was 1. This would be 5 minus 4. Indeed, it did work. It did work. It shouldn't have worked for any of you guys. All right, number 5. A little sketch. What are we doing? We are starting with the premise. We have negative f of 2x plus 1. I don't know why. I always like to have my vertical translations at the back. They don't have to, but I'm going to move it to the back and make it plus 1 at the back. Okay, and then I'm going to graph this thing. So I'm going to start with the original ordered pairs. So for F, which is the picture he drew, my points are 1, 2, 3, 4, -4, -4, and 0, 0. There's 2, 2. 4, 0, and 6, 2. Those are the original points. So what are my new points going to be? Well, what transformations are taking place? What does that do? Makes y negative? Or changes the sign on y? What does that do? Divides x by 2, and then that adds 1 to y. So there are 2 changes being made to y. It's being made negative, and then adding 1. One change being made to x, it's being halved. So my new x's will be -2, 0, 1, 2, and 3. Those are my new x's. And my new y's, I gotta make it negative and add 1. So that'll be 5. Make it negative and add 1. Make it negative and add 1. And there are my new points. I'll just plot those, connect them, and that should be enough. That should be it. Is that procedure? Oh, yeah.
When you're doing the translations, will you always do like the multiplication and division before?
PEMDAS.
Like,
PEMDAS. Yep. Yep. Everybody good with that? All right, looks like the next one has a bunch of parts to it. So looks like we need to put the numbers in our calculator. So here we go. We're gonna write a linear model. So here we go. pulled my fingers, Bill, it wouldn't work.
4.
Yep.
Are we putting at the years or years since 1998?
You can, there are no directions there, and I don't see anything in the problem, so you can do either one. Now, obviously, your equations will look different. Fundamentally, the answers will all be the same. I'm going ahead and putting in the years.
Okay.
I'm doing it that way, because it didn't give me any other, directions, yeah. And it's linear regression. Bless you. Anybody open to giving me an equation? I'm gonna call on someone. Charlie, you're always good for input. What'd you get for your equation?
Miss Ward, I forgot my graphic calculator today. I'm so sorry. I promise I won't forget it tomorrow.
Too busy celebrating your brother's birthday this morning?
Yes. This morning.
Okay, Charlie has let me down. Cole, you got an equation? What'd you get?
15.332 x plus.
Because one of us is wrong. I did not get that. Did you say 13? What'd you say?
15.
15? Anybody get 15 point something? Alberto, what'd you get?
I got y equals 18.225x plus 70.039.
Plus what?
70.039.
How did you define your x's?
0, like 0, 1, 2.
Okay, years since 1998. Okay, or 8, no, whatever it was. Anybody not do that? What did you get?
I got minus 36,300.
Yeah, so that is the difference. Somebody asked earlier, obviously the slope is gonna be the same. So Alberto and I have exactly the same slope. But because I used actual years and he used years since 1998, so I started in 1998, he started with 0. Obviously that's gonna throw off the y-intercept, right? Is that okay with everybody? So either one is perfectly fine since there's no directions. Okay. So you're fine, Alberto. I believe you. I think you have the right number there. All right, what percent of the variation is explained by the model? No matter what, you should have 99.570%. Now we're gonna find the residual for 2002, and I want you to do it by hand, and we'll do it with the calculator, but I want you to make sure you know how to find the residual by hand. So, if we're doing it by hand, it's actual minus predicted, right? And the actual value for 2002 is 140.8. The predicted value is what our calculator tells us for 2002. And that's 142.939. So subtracting, the residual is negative 2.139. And what would be the unit on that? That's 2.139 million subscribers. So if I had to interpret this is my calculation by hand, I'm gonna do it in a minute, I'm gonna get it off my calculator. But if I had to interpret this, it's not enough to say the model overestimated. Did the model overestimate?
Yes.
Yes, you have to be more specific. The model overestimated by 2.139 million subscribers in 2002. Are you listening to me? So I don't have to take off points when I grade these things tomorrow? Be specific. Yes, overestimated, good word, use it. But then by how much and what does it mean? Okay, now let's get it on our calculator. Oh, that's actually D. I just answered D. Now I'm gonna do a residual plot and then I can get this number right off my plot. So I'm going to go back to stat plot and make sure I'm graphing residual. I am. And when I graph my residual plot on my quiz tomorrow, I am going to make sure that I am labeling things. So, first, I'll leave that little blank because I'm starting at 1999 or 1998. Where does this go? All right, and this, I'm going to use these are going to be 1 millions. So I've got negative 0.839. And then for 2002, which is the one that the question asked me about, I got negative 2.139. Oh my gosh. How cool is that? Exactly. So there's my residual plot. How does that look to you? Is that kind of what yours looks like?
When we draw them, do they need to have like holes in them? Or does it need-
No. That's just, when you, in your stat plot, you can tell the calculator how to mark the points. And right now, I have marked, and you must too, little boxes to mark my points now.
Okay.
Those can be marked anyway. We can change that if you want to. All right, last question. Here we go. I got some weird thing drawn here for you. Yesterday, or whatever day that was, we drew one of these, right? Remember that with the asymptotes and all that? We need to make sure we can do that. All right, now it's already drawn. We're going to answer some questions. Tell me about the limit as x approaches infinity. That means we're going that way. What is the curve doing as you keep going that way? -3 from the top, right? It's coming in, -3 from the top. So your answer to that one is this. Approaching -3 from the top. Now, what about as x approaches 2 from the left. 2 is an asymptote, right? X equals 2. You got curve coming in on both sides. What is it doing as it comes in from the left side of that vertical asymptote? Negative infinity. See it going down? Remember, we talked about this. As you approach a vertical asymptote, you're going to do one of two things. You're going up or you're going down. That's all you can do. In this case, from the left, we're going down. All right, what about as we approach 3? Now, what's happening at 3? We have a hole, right? At x equals 3, don't we have a hole? And it doesn't matter, my head's the hole. It doesn't matter which side I come at it from, it's going to end up at the same place. So left or right is irrelevant if you're approaching a point. So the answer would be 5. Because that's the y coordinate of the hole. Right? How about negative infinity? What's happening as we approach negative infinity? That means go that way. It's approaching -3 again, but this time it's coming up from the bottom. When you approach a vertical asymptote, right? Going up or going down. When you approach horizontal asymptote, you're coming in from the top or you're coming in from the bottom of that horizontal asymptote. And finally, what happens as we approach 2 from the right side? Positive infinity. Okay with that? All right, let me hand back your last test, quiz. You can talk it over with each other. We'll be picking these back up, so please don't take off with them. William, Audra, Cole.
Are you on?
There's probably like 100. But yeah, there would be only like 100. Less than 100 probably. Oh really? Because they have to keep pushing it back.